Circuit breakers, specifically the BR series residential circuit breakers from CH Electrical in Eaton, and home line load centers from Schneider Electric, formerly Square D, are sometimes rated for multiple wires per terminal. In some cases, up to 3 wires can be connected to a single terminal. However, this is typically limited to number 10 to number 14 American wire gauge copper wires. It's crucial to understand that the maximum number of wires per terminal and the allowable wire sizes can vary depending on the specific breaker model and its amperage rating. Therefore, it is always recommended to consult the manufacturer's documentation or directly contact the manufacturer to obtain the most accurate information for the specific breaker being used. Ignoring these specifications can lead to unsafe conditions. When installing wires in a breaker, the torque ratings, often printed on the breaker itself, indicate the amount of force that should be applied when tightening the terminal screws. The purpose of these torque ratings is to ensure a secure electrical connection while preventing damage to the breaker or the wires. Applying excessive torque can deform the conductors or strip the threads on the terminal screws, leading to a loose connection. A loose connection increases resistance, which in turn generates heat. This heat can melt insulation, damage the breaker, and potentially cause a fire. Conversely, insufficient torque can also result in a loose connection, with similar consequences. To avoid these issues, it's essential to use a calibrated torque screwdriver or wrench and tighten the terminal screws to the manufacturer's specified torque value. This ensures a secure and reliable electrical connection that meets safety standards. When working with electrical systems, safety is paramount. Always energize the circuit before working on any electrical components. This involves turning off the circuit breaker that supplies power to the circuit. To verify that the circuit is energized, use a non-contact voltage tester or a multimeter. These devices can detect the presence of voltage without requiring direct contact with the wires. If voltage is detected, double-check that the correct breaker has been turned off. If necessary, turn off the main breaker to disconnect all power to the electrical panel. In addition to de-energizing the circuit, it's also important to wear appropriate personal protective equipment, such as safety glasses and insulated gloves. Safety glasses protect the eyes from debris or arc flashes, while insulated gloves protect against electrical shock. When selecting circuit breakers, it's important to choose breakers that are properly rated for the circuit they will protect. Circuit breakers are designed to trip or interrupt the flow of electricity when the current exceeds a certain level. This protects the wiring and appliances from damage caused by overloads or short circuits. The amperage rating of a circuit breaker indicates the maximum current that the breaker can carry without tripping. For example, a 15 amp breaker is designed to trip when the current exceeds 15 amps. To determine the appropriate breaker size for a circuit, it's necessary to calculate the total load in the circuit. The load is the amount of electrical power that will be drawn by all of the devices connected to the circuit. This can be calculated by adding up the wattage of all of the devices and dividing by the voltage of the circuit. For example, if a circuit will power a 1200 watt appliance and a 300 watt lamp, the total load would be 1500 watts. Dividing this by 120 volts gives a current of 12.5 amps. In this case, a 15 amp breaker would be appropriate. It is important to note that the National Electrical Code, or NEC, provides guidelines for sizing circuit breakers. The NEC specifies that the breaker should be sized no larger than the ampacity of the wire. Ampacity is the maximum current that a wire can safely carry. The ampacity of a wire depends on its size, material, and insulation type. The NEC also provides guidelines for directing the ampacity of wires in certain situations, such as when multiple wires are bundled together or when the wires are exposed to high temperatures. In addition to overcurrent protection, circuit breakers also provide short circuit protection. A short circuit occurs when there is an unintended connection between two conductors in a circuit. This can cause a very high current to flow, which can quickly damage wiring and equipment. Circuit breakers are designed to trip very quickly in the event of a short circuit, typically within milliseconds. This rapid response helps to minimize damage and prevent fires. There are two main types of circuit breakers: thermal-magnetic breakers and electronic trip breakers. Thermal-magnetic breakers are the most common type of circuit breaker used in residential and commercial applications. They use a bimetallic strip to detect overloads and an electromagnet to detect short circuits. When an overload occurs, the bimetallic strip heats up and bends, eventually tripping the breaker. When a short circuit occurs, the high current energizes the electromagnet, which trips the breaker. Electronic trip breakers are more sophisticated than thermal magnetic breakers. They use electronic sensors to detect overloads and short circuits. These sensors can provide more precise and faster tripping than thermal magnetic breakers. Electronic trip breakers are typically used in industrial applications where precise protection is required. When installing circuit breakers, it is important to follow the manufacturer's instructions carefully. The breaker should be securely mounted in the electrical panel and properly connected to the wiring. The wires should be stripped to the correct length and properly tightened in the terminal screws. It is also important to label the circuit breakers so that they can be easily identified. This will make it easier to troubleshoot problems and turn off the correct breaker when working on a circuit. Regular maintenance of circuit breakers is essential to ensure their proper operation. Circuit breakers should be inspected periodically for signs of damage or wear. The terminals should be tightened to ensure a secure connection. The breaker should also be tested periodically to verify that they are tripping properly. This can be done using a circuit breaker tester. If a circuit breaker fails to trip when it should be replaced immediately. A faulty circuit breaker can pose a serious safety hazard. In summary, understanding the ratings and specifications of circuit breakers is essential for ensuring electrical safety. Always consult the manufacturer's documentation for accurate information and follow all applicable codes and standards. In addition to the points already covered, it's crucial to understand the different types of circuit breakers available and their specific applications. Ground fault circuit interrupters, or GFCIs, are designed to protect people from electrical shock. They work by monitoring the current flowing in the hot and neutral wires of a circuit. If there is a difference in current between the two wires, it indicates that current is leaking to ground. This can happen if someone touches a live wire or if there is a fault in an appliance. GFCIs are designed to trip very quickly in the event of a ground fault, typically within milliseconds. This rapid response can prevent serious injury or death. Arc fault circuit interrupters, RFCIs, are designed to protect against fires caused by arcing faults. An arcing fault occurs when there is an unintended electrical discharge between two conductors. This can happen if the insulation on a wire is damaged or if there is a loose connection. Arcing faults can generate a lot of heat, which can ignite nearby combustible materials and start a fire. RFCIs are designed to detect arcing faults and trip the circuit before a fire can start. Dual-function circuit breakers combine the functions of both GFCIs and RFCIs. They provide protection against both ground faults and arcing faults. Dual-function breakers are becoming increasingly popular because they offer comprehensive protection in a single device. When selecting circuit breakers, it is important to consider the specific needs of the application. For example, GFCIs are required in bathrooms, kitchens, and other areas where there is a risk of water exposure. RFCIs are required in bedrooms and other areas where there is a risk of arcing faults. Dual-function breakers can be used in any location where both GFCI and RFCI protection are desired. In addition to the types of circuit breakers already mentioned, there are also surge protective devices, or SPDs. SPD are designed to protect electrical equipment from voltage surges. A voltage surge is a sudden increase in voltage that can damage or destroy sensitive electronic equipment. Voltage surges can be caused by lightning strikes, power outages, or other electrical disturbances. SPD work by diverting the excess voltage away from the protected equipment. They are typically installed at the electrical panel or at individual outlets. When selecting SPD, it is important to consider the surge current rating. The surge current rating indicates the maximum amount of current the SPD can safely handle. The higher the surge current rating, the better the protection. It is also important to choose SPD that are listed by a recognized testing laboratory, such as Underwriters Laboratories, or all. UL listing indicates that the SPD has been tested and meets certain safety standards. Proper grounding is essential for electrical safety. Grounding provides a path for fault current to flow back to the source, which helps to trip circuit breakers and prevent electrical shock. The grounding system should be properly installed and maintained to ensure its effectiveness. The grounding electrode system typically consists of a grounding rod or plate that is buried in the earth. The grounding electrode is connected to the electrical panel with a grounding electrode conductor. The neutral conductor is also connected to the grounding electrode at the electrical panel. This creates a low impedance path for fault current to flow back to the source. All metal enclosures, such as electrical panels, junction boxes, and appliance housings, should be bonded to the grounding system. Bonding ensures that these enclosures are at the same potential as the ground, which reduces the risk of electrical shock. The NEC provides detailed requirements for grounding and bonding. These requirements should be followed carefully to ensure a safe and effective grounding system. Electrical inspections are an important part of ensuring electrical safety. Electrical inspections are typically performed by local government agencies or by qualified private inspectors. The purpose of an electrical inspection is to verify that the electrical system meets all applicable codes and standards. During an electrical inspection, the inspector will examine the wiring, circuit breakers, outlets, and other electrical components. The inspector will also check for any safety hazards such as exposed wires or overloaded circuits. If any violations are found, the inspector will issue a report listing the required corrections. It is important to correct any violations promptly to ensure the safety of the electrical system. Regular electrical inspections can help to identify potential problems before they become serious safety hazards. Electrical safety is a shared responsibility. Everyone who works with electricity should be properly trained and aware of the potential hazards. Homeowners should also be aware of basic electrical safety practices, such as avoiding overloading circuits and keeping electrical cords in good condition. By following safe electrical practices, we can help to prevent electrical accidents and injuries. When working with electrical systems, it's always best to err on the side of caution. If you are not comfortable working with electricity, it is best to hire a qualified electrician. A qualified electrician has the training and experience to safely install and repair electrical systems. Trying to do electrical work yourself without the proper training can be dangerous and can lead to serious injury or even death. In addition to the safety aspects of electrical work, it's also important to consider the efficiency of the electrical system. An efficient electrical system can save money on energy bills and reduce the environmental impact of electricity consumption. There are several ways to improve the efficiency of an electrical system. One way is to use energy-efficient lighting, such as LED bulbs. LED bulbs use significantly less energy than traditional incandescent bulbs and last much longer. Another way to improve efficiency is to use energy-efficient appliances. ENERGY STAR certified appliances meet certain energy efficiency standards and can save a significant amount of energy over their lifetime. It is also important to properly insulate the home to reduce energy loss. Insulation helps to keep the home warm in the winter and cool in the summer, which reduces the amount of energy needed to heat and cool the home. Another important aspect of electrical systems is surge protection. Electrical surges can damage or destroy sensitive electronic equipment such as computers, televisions, and appliances. Surge protection devices, or SPDs, can protect electrical equipment from voltage surges. SPD are typically installed at the electrical panel or at individual outlets. When selecting SPD, it is important to choose devices that are properly rated for the voltage and current of the electrical system. It is also important to choose SPD that are listed by a recognized testing laboratory such as Underwriters Laboratories, or UL. In summary, electrical systems are complex and require careful planning, installation, and maintenance. By following safe electrical practices and using energy-efficient equipment, we can ensure a safe, reliable, and efficient electrical system. Remember to always consult with a qualified electrician for any electrical work that you are not comfortable doing yourself. This will ensure that the work is done safely and correctly.